Hello friends, welcome back. So in this session we will learn dynamic test, exception test, test timeout and extensions in JUnit 5. So first we will see dynamic test. So what is dynamic test? Dynamic test is nothing but a new kind of test that generated dynamically with the help of @test factory annotations. So we can say that in JUnit 5 one test factory is provided, and under this test factory we will configure our test cases, and that test cases will automatically generated based on your configuration. So thus the standard @test annotation in JUnit Jupiter described in annotation is very similar to @test annotation as in JUnit 4. Both describe method that implement test cases only. These test cases are static. Whatever we are using, either JUnit 5 or JUnit 4 @test annotation, that test cases are static. But if you want to create the test dynamically, then we can use test factory instead of that one. So these test cases that are written using @test annotations cases are static in the sense that they are fully specified at compile time and their behavior cannot be changed. Anything happen at runtime. Assumption provided provide a basic form of dynamic behavior, but the internally rather limited to their expressiveness. Okay, so we can use test factory to create the method. So what is the rules to define the test factory? Test factory annotation method, we have to create one method that should be marked with @test factory annotation. And but test factory method, whatever the method we are creating with marked @test factory annotation, that method is not itself a test case but rather a factory of test. That is a factory of test cases. Thus dynamic test is the product of a factory. Technically speaking, you can say test factory method must return a single dynamic node or stream or collection or iterator or any other array of dynamic node instance. Instantiable subclass of dynamic node are dynamic container and dynamic test. Dynamic container instance are composed of a display name and the list of dynamic child node, enabling the creation of arbitrary nested hierarchy of dynamic node. Dynamic test instance will be executed lazy, enabling dynamic and non-deterministic generation of test cases. So any stream or collection or array or iterator returned by @test factory will be properly closed by calling stream.close method, making it safe to use a resource such as the files of or any database connection or any other resources that you are making a connection to that resources. So that will be closable automatically, that will be closed. Okay, as with @test method, test factory method must be private or static, and many optional declarative program parameters to be resolved by the parameter resolver. Okay, dynamic test is the test case generated at runtime. It is composed of display name and executable. Executable is nothing but this is a functional interface. Executable is nothing but a functional interface, which means that the implementation of dynamic test case can be provided as lambda expression or method reference. We will see this one. Okay, and dynamic test life cycle. What is dynamic test life cycle? Suppose you created some tests dynamically, then how at the rate before each, before, after will be executed. The execution life cycle of dynamic test is a quite different than it is for the standard at the rate test case. Specifically, there are no life cycle callback for individual dynamic test. All the test cases, this means that at the rate before each and after each method and their corresponding extension callbacks are executed for a test factory method, but not for each dynamic test. Suppose you have defined some life cycle like at the rate before each, after each. How will you define at the rate before each and after each? Because test you have not created, and that will be created dynamically. So in that case, if you have specified any life cycle before each or after each, that will always executed once. It will not execute more than one. If you have created 10 dynamic test cases or one dynamic test cases, it will executed only once. Okay, in other word, if you the factory method but not for each dynamic test. Okay, in other word, if you access field from their instance, which is lambda expression for dynamic test, thus field will not be reset by callback method or extension between the execution individual dynamic test generated by test factory. Okay, so this is dynamic test that test cases will be created dynamically. So let's see the example of this one now. So here if you see, we have created one dynamic test demo inside new package com.techhub.demo.junit.dynamic. So under this one we have created one file dynamic tests demo. Here if you see, we have not created any test cases, but can you imagine how many test cases will be created? See, here we have created only test factory, and inside this test factory, this is just message I am logging first. And here if you see what I have created, I have created a list of dynamic test, and these are the input for my dynamic test cases. These are the inputs. This one is an input 1 2 3 4 5 6 7 8 inputs are there, and these are the expected output. This is a palindrome, yes, that's why this is a true. This is a palindrome, that's why this is a true. This is also palindrome, this is also a palindrome, this string is also a palindrome, but this last three strings are not palindrome, so this expected output is a false. So like that we can give input and output for. And here we are running one loop, and inside this loop we are iterating these inputs, and this inputs I am taking as an input parameter, input variable, and expected that I am taking from the output from the same index array. So input and output. On the basis of input and output, what I am doing, I am creating here dynamic test using this static method of dynamic test. This is a dynamic test one interface that is available under org.junit.jupiter.api dynamic test. Inside this one dynamic test, one static method is there. That method is taking two parameters. First one is a string, that is the nothing but display name of your test, and the second one is a parameter that is a type of executable. Executable objects you can create in this way also, no issue. This is executable only, currently that is lambda expression only, so we were giving that only. Yes, this is lambda expression. So as we have already seen here, that is a functional interface. Executable is a functional interface, which means that the implementation of dynamic test can be provided as lambda expression or method reference. Okay. So here what I am doing, assert equal expected, this is our expected from this one, this is our actual output, this is our expected output. Expected out means it should be true, and what it is coming really, whether it is coming true or false, so we can check like that here. The same thing I am doing here also. So what I can do here, I can remove this one, no issue, and instead of this one, what I can give, expected simple. I can give this one also, because that is a lambda expression, no. Okay, one more braces we have to give here. Yes, that is also fine. This is our lambda expression that we can give in this way, or this much code we can directly copy. This much code, instead of this execution, we can directly copy. That is also fine. That is also fine. Okay, because this is a lambda expression. So this will create now how many test cases, how many times this loop will run, that many test cases will be created. Currently this is 8, I think 1 2 3 4 5 6 7 8, so 8 test cases will be created. These were the input for, these are the output for that one. So if I run this one, you will see 8 test cases will be created and executed. So this is nothing but a dynamic test. You can create the test cases at runtime. You can just specify your configuration. So if you see here, how many test cases run, 8, but we have not defined any test case here, only factory we have defined. Your JUnit 5 will use this test factory to create the dynamically test cases. Okay, and if I open here, you will see these are the dynamic test cases. This is the name, you can give any name, no issue. Currently I am giving this name only. If you want to give the some different name like string, I can give that one also, like test case display name. So sorry, dynamic test plus I. Simply I am just giving in this way. You can give the convenient name, whatever you want, however you want to generate dynamic test case name, you can give. Currently I am giving in this way. Okay, but we should avoid this concatenation of a string. We should not do like that. Instead of that one, we can use string builder or something. Okay, that is fine. Now you will see the test cases name will be like that, 0 1 2 3 4 5 6 7. Okay, so like that we can create the dynamic test cases. Okay, but as far we can see here, this same type of operations we can do through the one test case only. So why 7 cases? If one test case is fine, no, because this inside this one test cases we can give this inputs and outputs, and we can call the same test case multiple times. How we can call this one? We can use parameterized test case, however we have seen in the previous session. Okay, so you use that one, or you can do in this way, in this way also, that is up to your choice. Okay, so this is a dynamic test. To do the dynamic test creation, we have to use test factory, annotation test factory. Okay, next one is the exception test case. Exception test case means when your method is throwing exception, when your method is throwing exception, for that one, how can you do the testing? How can you write the test cases? It is quite different from the JUnit 4. In JUnit 4, we were using the exception test cases checking is totally different from JUnit 4. In JUnit 5, The exception and message of exception can be tested in simple test case only without defining any rule. Following is the way that you can use to write the test case for exception. We can use assert throw. We can make this assertion assert throw, and assert throw what? This is that exception that you are expecting, and this is your execution. Executable is nothing, executable, this is executable. So this is executable, that is nothing but the lambda expression only. So that one we can use to check the exception in your test case. So let's see the example. Exception test demo. Okay. So if you see here, exception test demo, so here what you can see, so this one is our assertion dot, if I show you here, assertion dot assert throw. So you see here, first parameter is a class, that is expected type, and the second one is an executable. What we have given here, execution. So that is it is wrong actually. Yeah, so this should be this executable. Executable is what? That we have already that we have seen in this test case, dynamic test. Executable is an functional interface, which means that can be implemented as dynamic test case, can be provided as a lambda expression. Okay, so this is nothing but the executable only. So the same executable we can give here also, assert throw executable. So what I can do, I can create lambda expression here also, no issue. Executable. Okay, so this is our executable, and this executable can be implemented as a lambda expression. Simple. That's it. And this implementation, assert throw, this one, data repository dot get object null, you can give here, no issue. That's it. And instead of this one, what you can give now, you can give this executable reference. This is our executable reference, and that reference you can pass here. So that is also fine. So here because in this test annotation, same as JUnit 4, in JUnit 4 how we were testing for exception, we were using here expected variable of a test annotation. Inside that one we were specifying what is the expected, but now in JUnit 5 that is removed, that is not there. So you have to test for exception case, you have to test in this way only. Assertion dot assert throw, if it is a throwing what, this type of exception, here you have to give the type, my custom exception, that is a type, dot class, and execute this executable, execute. And if this is a passed, yes, if it is a passed, then you can go for the message also, assert equal, because this is exception, and exception exception get message method will be there. So using this one you can get the message also. So like that you can test for exception case in JUnit 5. Yes, it is working. Exception test method is entering, and if you see this test case is passed. Okay, so like that it will work, because this we have already seen in JUnit 4 also, this data repository dot get object, if it is a null then definitely it is a throwing exception only, this one. Yes, this one is that code. That is throwing the exception. Okay, so like that you can check for exception case also in JUnit 5. Okay, next one is the timeout test case. Timeout means if you want to check for performance also, suppose you are doing some data from the array, removing some element or sorting the element or doing some, you are implementing some algorithm, and that in algorithms you know it should max time it should take that much only, it should not take more than that one. If your algorithms taking more than your expected time, then you should say your test case is failed. It is not meeting the requirement of a time also, whatever the in how much time your method should be executed, but it is executing beyond to that time. So that's why you can test for timeout of your test case, and that you can do using @timeout annotation. Before how we were doing, before we were doing through test annotation only. Inside this test annotation we are specifying timeout, but now that option we don't have at all. We have to use @timeout annotation. So let's see the example. Okay, and the timeout annotation allow one to declare that the test factory, test template or test lifecycle method should fail if its execution time exceed and given duration. The time unit for the duration default to second, but it can be configurable also, because the default time that will be in seconds only, default time. We will see this one. Okay, so here you can see test timeout demo. Inside this one you can see, so we are testing timeout for what? For this array sort method is there. Yes, array sort. So this sorting element of from the array, how much time it should take, so that much we are testing here. So first one, this is a timeout. See here we are using timeout with the test annotation. Timeout one means in 1 second, if your test case is executing, then it is fine, otherwise it should be failed. So just I am disabling this one, disable this one first, and I am running this one above 1. So this will work fine, because 1 second it's not taking that much time to execute. Okay, it's executed, but this is a 1 second only, but I want to specify that time in some other unit. Other unit means microsecond. Now this is not a second, that is a microsecond. If it is a microsecond, then definitely in 1 microsecond this task will not be finished, so definitely this will be failed. Yes, it's a failed. What it is giving? Timeout test timed out after 1 microsecond. So you can specify any unit here. This is our unit. Currently we are taking one is what? 1 is microsecond. You can give 1 day, 1 hour, 1 microsecond, 1 millisecond, 1 minute, 1 nanosecond, 1 second, but up to your choice. Whatever you wanted to specify your unit, you can specify in this way also. Okay, so this is the one way you can do timeout. You can do the timeout in your test cases. Another one is also there, that you can do using asset timeout. That is quite similar with how we were checking for the exception. Means test timeout first should be what? First should be your duration. Timeout first should be your duration. Second is nothing but your executable. How we were creating executable, the same, that only executable. Yeah, so that is executable only. You can do timeout in 2 ways. One is you can use @timeout annotation, and another one you can use @assert timeout assertion. You can use assert timeout assertion, and assert timeout assertion is taking two parameter. First one is your duration and second one is your executable. This executable, if it is not executing within this much of time, then definitely it should be failed. So if I run this one, you will see whether this is a passed or failed. It's failed. What it is saying, unit must have an estimate duration. Okay, so you can give here some seconds or something. In that case, that will work fine. Seconds I will specify. This test case will be passed because it is not taking 1 second at also. So now this test case is passed. Yes, it's passed. This I am actually disabling. Okay, so like that you can use timeout in your test cases. Okay, the last one is extension. What is extension? See, we have already seen a fixture in our JUnit 5. Before all, after all, before each, after each. So suppose if that fixture we have to write into multiple classes. Suppose we have created the pre-process and post-process task for each test cases, but that should be shared among the so many files. I don't want to write for after all, after each, before each, after all, before all. I don't want to write that code in every classes. I don't want to repeat that code. Then what should I do? I can go with the extension. Extension is removing that issue, whatever if code duplication we are facing, because if the same code only we have to write into multiple test cases into the fixture before all, after all, into that annotations, so that we can remove or we can add that into an extension, and we can add that extension into our test class. That is very simply. So in JUnit 5, Jupyter provide extension author callback that can be used to tap into the life cycle event of test. The extension model provides several interfaces for extending test at various points in the test execution life cycle. Execution life cycle is nothing but the fixtures only. After all, before all, after each, before each, all that only. Extension authors are free to implement all or some of these life cycle. You can implement all the life cycles or you can implement any one of them. It is up to your choice also. Okay, so extensions you can register in your test case with 3 ways. One is declarative via extend with. So first we will see how we can register the extension in a declarative manner, and before to see what we have to see how we can create the extension. Okay, so let me open this extension property. So here these are the extensions that I have created. These 3 extensions I have created here. Extension A, extension B. You can give any other name, like database extension that is making connection to database or some resources. You can use any name that is not like that. You can use extension A or B or C because this is a class name. You can give any of the class name. So inside this extension A, I want to implement the life cycle or I want to use the fixture before all. Then how I can do that one? You have to implement before all callback interface. If you want to implement before all method, before all before all annotation we have already seen. So if we want to create that fixture for so many classes, then we have to use the extension, and that extension, in that extension you have to just implement the corresponding fixture, like before all callback. This is for before all. After all callback. This is for after all. This is before each callback. and this is after each callback. So these are the four fixtures that is provided here. Here that is in form of interface only, and that interfaces we are going to implement into extension. And here if we implement this one, then definitely before all method we have to override, and if we are implementing after all, then after all method we have to implement. If it is before each, then before each method we have to implement, and if it is after each, then after each method we have to implement. Currently implementation is nothing but just I am printing messages only, message in the same way like extension. This is the extension name, this is the entering into before all method, that's it. Simply after all, before each, after each, simple. So this is one extension. In the same way I have created another extension. You can create n number of extension, no issue. So 3 extensions I have created here. Okay, so in this way you can create the extension, that is very easy. Okay, so now first approach is registering extension with the declarative via extended with annotation. So via declarative, how can you include the annotations into your class? You can include the extension in your class in this way, very simple. Extend with, and inside this extend with you can specify your extensions. That is an array, that is an array of a class, and inside this one you can give your extension 1 2 3 n number of extensions you can give here. And if you run this one, so before to call this test method, your extensions will be executed. You can see. Yes, see. So here first it is before all, last after all, and in middle before all, because 2 are there. Why it is 2? Why it is 2? Because 2 extensions are there. Extension A, this is before all for extension A, before all for extension B. And if I give in the reverse manner, then which extension will be called first? See, extension B will be called first. It depends on your order, how exactly it should be executing. Then before all each, then after all each of which one? Because A is called before, so before, after each A will be called first, then after each of B will be called, and then after all will be called. You can call in this way also. Okay, and this extend with the annotation you can mark on top of method also, if you mark on top of methods, then before all and after all will not executed, because that is executed at a class level. But now this extension you are marking at method level, so only the before each and after each is calling. Before all and after all is not calling, because you are not marking this annotation at a class level. And if for another method, see, if we have created another method test2, this is our test2, and for this test2, if you see, it will not call now, it will not call. See, entering into test t only, but it is not calling any extension, because that extension we have marked specifically for this method only. But if I mark this annotation on top of class, then this annotations will be considered for all the methods. Yes, for all the methods. So like that you can use this extension in a declarative manner. This is a declarative. Another one is a programmatically via @register extension. That is very easy. That also you can create the object programmatically. Second one is a programmatically via @register extension. So this one you can use in this way, very simple. Just you have to create your extension, and that should be static. that object reference or that variable should be static only. So static extension A, and extension A is equal to new extension A, register extension B. Very simple. Just, and that static variable you have to mark with the register extension annotation, then only it will be considered as extension. If you don't marking this one, that will not give any impact here. It will not call at all, because you have to tell to your JUnit platform, these are our extension and I want to execute them. So how will you tell that one? You have to just mark these annotations. Okay, so if I run this one, you will see that it will execute both, first A then B. If I change the order, then first will be B. It is depending on your order. Sorry, it is not executing on this. Okay, yeah, fine. It is, we are also not able to show, means it is not executing in the same order, but it is executing. Okay, so in this way we can use extension in programmatically. Here one advantages we are getting. What advantages? We can pass here some values in the constructor. If we want to initialize, then we can give some values into our extension here. See, because in this declarative manner, if you see, we don't have that control, because we are just specifying here classes. We cannot pass any value while creating this extension. While creating this extension, we cannot pass any value and we cannot initialize it with specific value in declarative manner. But in programmatic manner, we can specify, we can pass the value in constructor and we can initialize it as per our choice. We can do that one. Okay, so that is up to our choice which one we wanted to use. So this is a programmatically via register extension. Third one is an automatically via Java service loader mechanism. That it will automatically, even you no need to specify this one annotations or this extension, you no need to specify any of them. It will automatically register. So how it will be? That is called automatically via Java's service loader. How will you do? So first you have to do what? You have to create one file. You have to create this file. This is a file name as it is, org.junit.jupiter.api.extension. This is one class, text class, simple. Under what? Under src meta inf under services. You have to create this class first. So we have already created this class here. You can see we have created in under our source, inside this source meta inf, under this meta inf services. So this is our path that we are specifying. Under source, under src means source, under src you have to create meta inf, under meta inf you have to create services. So this is our directory, these are the folders. So we have created under src we have created meta inf, under meta inf we have created service folder. Under service we have to create org.junit.jupiter.api.extension file. You no need to give any extension. If you want to give .text or something, you can give, but it is not required also. Okay, and under this one what you have to do? So this is our that file. Under this file you have to give your extension class name, fully qualified class name. So extension C, I am giving only extension C. You can give any other, like extension A, extension B, extension C, whatever you want you can give, but currently I am giving only extension C. This is nothing but fully qualified class name, com.techhub.demo.junit. Where is com.techhub.demo.junit.extension? This one. And under this extension, if you see com.techhub.demo.junit.extension, under this one extension C class is there. So just you have to give that here. So now this is ready for automatically registration of extension. And now just you have to do, you have to provide your VM argument in run configuration. Which one? These are, that's it. So just copy this one. You can get it from JUnit official website, no issue. that detail will become here. Okay, so just copy this one, and how you have to run this one. So while running you have to provide those. So I have created here auto extension register demo. So you can see here, this is our auto extension register demo test API. Here is the one test method is there. Here you can see I am not using any @extended with or register extension. I am not using here that annotations. I am not using here extend with or register extensions. I am not using here to register the extensions. I am not registering extension here via programmatically or via declaratively. I am not registering. So I want to register automatically extension C, because extension C configuration I have already given into meta-inf under service under this file I have given already. So what I have to do, I have to run in different manner. So run as run configuration. What you have to do, run configuration. Under run configuration, what you have to select, you have to select your JUnit. You can delete those. Wait, I will just delete. These many configurations are there to run that one, so delete them, no issue. Okay. So here you have to create your run configuration for JUnit. Just select here, double click here. Suppose if it is not there, if this extension is not there, then just you have to double click on this JUnit. Okay, let me go once again, delete this one. So just right click here, run as run configuration. Under this run configuration, select JUnit, double click on this one, and here you will see you have to run from this project this file, and from this file one method is there that you want to test, and just go to arguments. Under this arguments, what you have to do, you have to provide these value. What it is saying, JUnit .junit.jupiter.extension auto detect. You have to auto detect what extension, that should be enabled true. That's it. So just you have to give that here. After this EA, you have to give this one and apply and run. Simple. Now you will see automatically your extension C will be registered, and it is calling here. See, entering into before all, where C extension, where we have registered C extension, we have not registered. Automatically it is registering. Simple. That's it. Next time you no need to do configuration. One time you did the configuration, you run, just simply run as JUnit. Simple, it will run. So this extension is registered here. So you can do in this way also. So that is only about extension in your JUnit 5. Okay, so in the next session we will see conditional test, repeated test and nested test in JUnit 5. So I hope you like this session. Please subscribe my channel, and we will see you in the next session. Till that, bye bye and thanks for watching.